All right. Don't know if anybody's here yet. I haven't actually checked. Brianna, Jetta. All right. Looks like we have some people coming in. No joke today, mainly because I've been dealing with trying to get your exam all set and ready to go. Let's see how many people. We have 157 people. You guys are diligent. Um, all right. So the way I like to run this is let's just briefly review all the things that we have. And then after that, I will just kind of turn you guys free to ask me questions about either, well, about the homeworks or the T1 overview or about, whatever other things you may have questions about. So we'll start out here. Like I said, I'm just going to do a quick 10-minute review about what's actually on the test. And then we'll get right into questions. So this is, if you come down here, this is our web page, right? All of your lecture notes are here. We try to upload them to Submity as well. Um, Introduction, there's not really much there. We just introduce the course. We do kind of talk to you about the three doubles. You should be actually pretty close to being able to read that now, except I think we use a for loop. So once we get to for loops, you will have most of what you need for that. But you should, kind of understand this concept of um, syntax and semantic errors and how we write code. Moving on, the next lecture was largely Python as a calculator, but we use this to introduce things like whole numbers and floating point numbers and other operator precedents, variables. We introduced the concept of using variables to actually hold values that you're interested in, and we talked about some math functions. We talked about the print function. I don't think at this point we talked about end and set, but we'll get to that as well. And we talked about putting your code in a file, which quite honestly you'll have to do for this test, but also is in general something that is pretty important. You need to be able to do that. There were some exercises. And again, those mainly dealt with some mathematical formulas, precedents, and variables. Lecture 3, we introduced strings. So there are a number of string functions that we use. We talked about how to combine single and double quotes. Remember that whatever you use to start a string is the only character that can be used to end it. So for a single line string, it's a single quote or a double quote. For a multi-line string, it would be 3 single quotes or 3 double quotes. We talked about escape characters. You should actually know these 5 escape characters. You should know string operations, concatenation, and replication. And that was, and then we had these other string options, these other functions like length, min, and max. Here we go. And then we got into the print function even a little bit more, and we had this sep and end functions that you should know. Flush is going to be very important as you get into more complicated homeworks, but it is less important on the test. Again, make sure you know that because it will help you out moving forward when you're trying to debug your programs and you're wondering why you're in loop 1000 and nothing's going wrong, and it turns out that because you didn't have flush set, it actually blew up in loop 1200 or something. We also talked about user input. The really important thing you want to remember here is that all integers come in, or all inputs come in as strings, right? So no matter what you enter here, whether you enter a sentence or a number or a floating point number, after that first input line, X will be input as string. If you want it to be something else, in particular, if you want it to be a float or an integer, you actually need to do the explicit conversion. And we asked you to do it in this format as much as possible. input the string. If you're running on submiti, print the string back out again, and then after you've done both of those operations, then convert it to the type you want. This will help you debug your code on submiti. We're not doing this because we're mean. We're doing this because if we don't do this, you can't see what inputs we're providing to your program. And when you start having issues with submiti, you have no idea what inputs we put in that triggered whatever error you're seeing on your program. So please get used to doing this. You do not need to do that. You don't need to do the 3-step process on the test. We won't grade you on that part. If you do it, it may make our lives a little easier, but it is not required and it will not be taken off. Similarly, if you do print out, x equals input, some prompt, print x, x equals int x, that's also allowed. It's possibly preferred, but either way will be accepted as correct. Unlike your homeworks, we will actually be looking at your code and doing some analysis to see, it's not an all or nothing. If you don't match our output exactly, you don't necessarily fail. You could, it's up to you how badly you do on the homeworks. All right. These summaries are pretty good to look at. They'll at least tell you what we think we were talking about. So that's useful. Exercises. For the exercises, the one thing you want to note on the exercises, make sure you understand how to do these, right? In particular, things like this, little tricks to play with string variables where you're not allowed to use loops are actually a lot of fun, little brain teasers. You're required to be able to do those. Lecture 4, we got into functions and modules. We pulled out some functions like length function for strings. We showed you some functions for math. You should know about these math functions. You should know the ones that exist in the base Python installation. And you should also know how to... I'll get into that later. You should also know the functions that are allowed on strings. Make sure you can do find. Make sure you know how to do all the change of case functions. Make sure you know and understand strip. And remember that there's also an else strip and an R strip that works the same as strip, except they work only on the left or right ends of the string explicitly. Okay, these are all cool. Remember that the output of a replace call, for example, is a string. So you can pull replace calls. You can string replace calls together to do multiple changes to an input string, cascading changes. We talked about a format method that allows our print statements to have more precise answers. Whatever answer we are looking for, you can do it with a format statement, because format statements are what I use. And then we also introduced this concept of modules, and we did it with the math module. So make sure you can import modules, make sure you can import the math module, and make sure you know how to use them. Make sure you know the multiple ways of importing a module and how that affects how you access the variables and the functions from within it. Program structure we are not going to be as concerned about on the exam, but part of the reason for having program structure is because if you do things this way all the time, you will find, well, one, it helps you organize yourself, and two, other people can read your stuff better. You want your stuff to be organized because you want to do a good grade, and you want to know what you're doing. You want us to be able to read your code because if we can read your code, there's a better chance we will give you more points, right? If we can't understand what it is you're doing, it is harder for us to say, yeah, I think this person deserves, a 75% as opposed to a 0. So on the specific question. So please, try to organize your code. We will not be grading you on it. And then we just kind of walk through some practice problems. All right, again, make sure that you know how to do all these things. Make sure that you know how the help function works. It will help you out extensively during your exam. Certainly, you can find out all of the string functions, etc., by using the help function. Okay, exercises. You should be able to do math in Python. That's important. Let's see, Python functions. We now talked about how you can write a function. Make sure you know how to do these operations, right? Make sure you know how to write a function like area circle, and make sure you know how to call a function. I'm seeing some issues with that in some of the homeworks and lecture exercise submissions. You're not quite getting this writing a function and calling a function kind of concept. So make sure you can do that. Make sure you know what arguments are. Right? In this example, the argument is 1. It's the value that's being passed into the function. The parameter is the radius. The radius acts as a local variable within the function. The only thing is it's initialized to whatever the value of its corresponding argument is before the function executes the body. So for this particular set of calls, radius is the parameter. 1 is the argument. We execute an implicit radius equals 1 before the start of this function, and then within this function, radius has the value, or at least starts with the value 1 that we defined here. Remember about returning values from a function. If you want to assign the value or you want to maintain the value, you need to return it. Printing up in this function is not the same as returning a value. A function that doesn't have a return value, or a function that returns nothing, has a return statement with no value at the end of it, returns the special value none. So if you run into none, you're probably forgetting or missing your return statement. We talked about flow of control, be able to trace your programs, be able to trace our programs and tell us the flow of control. And then we have this nice little example. This is in the Lecture 5, the code written in class down here for Lecture 5, that shows you how to write a module, your own personal module. In this case, it's called Lecture 05 _ surface and area, and it has functions to compute the area of 3 different geometric objects, a circle, a cylinder. I'm sorry, 2 different. I thought we had a sphere too. Anyway, a circle and a cylinder, and it shows you how to call them. You can also import this, and the exercises in here actually show you how to import that and use those from a new program. Okay, that's the main ideas from 5. And again, I'm just kind of skimming over these really quickly just to tell you the concepts that you should know, and then I'll answer questions on them as soon as I get through, well, I think 2 more. Here's the lecture exercises. Come on. There you go. We talked about decisions. We talked about Boolean operations. We talked about using relationals to take 2 inputs that are not Booleans and to turn them into Booleans, and this works for strings, it works for floats, it works for integers. The relational operators compare things for less than, greater than or equal to, less than or equal to. And we also have relational operators for equality, which is the double equal sign, not a single equal sign, and for not equals, which is the exclamation point equal sign. And we talked about how capitalization, if you're comparing strings, capitalization matters, right? Capital A-R-A-R-T is not the same as lowercase a-r-t. And in fact, what we find out is that all the capital letters come before all of the lowercase letters. So capital A comes before lowercase a. And in fact, capital A comes before lowercase z. So make sure you remember that. That's called lexicographic order. It's alphabetical order, but with symbols other than letters in it, and with capitals and lowercase actually both having different values, having different ordering. We took these conditions and we showed you how to build if statements. We told you how to build if statements. You can use multiple if statements. You can use an if and an else. You can use an if, an elif, and an else. An if statement has to have exactly one if clause. It can have as many elif clauses as it wants, and it can have 0 or 1 else clauses. And as many means 0 or more elif clauses. So exactly one if, 0 or more elif, 0 or 1 else blocks. We then introduced the concepts of and or in Boolean logic. And we said that and returns a true. It takes two Boolean operators or two Boolean values and returns a true if both Boolean values are true, returns false otherwise, or it's kind of the opposite. It takes two Boolean values and returns true if either of them is true. It returns false only if both of them are false. And then we introduce Boolean logic not, which takes any true value and turns it into a false value, and any false value and turns it into a true value. Make sure you understand Boolean logic. You will need to know Boolean logic for the rest of your lives. We'll talk about it a little bit more. We'll talk about some other rules for simplifying it in a future lecture, but this is important stuff. Make sure you can use ifs. Make sure you can understand Boolean logic. Some exercises. All right. Lecture 7, we introduced another data type, and this data type is called a tuple, and a tuple allows us to group values together. Tuples and strings, right, in lecture 9 or something like, or lecture 8, we get into lists. We're not into lecture 8. This is a tuple. This is not a list. Lists are not on the test. Tuples are. Tuples are immutable. If you have a tuple, x equals 4, 5, 10, you can access each member of the tuple, but you cannot assign back to it, right? If you try to assign back to it, you get an error. So tuples, and that holds for strings as well. Strings are also immutable. You can think of tuples as a multiple assignment. You can think of them as coordinates in a coordinate space, x and y coordinates, x, y, z. If you have a 3-tuple, tuples can be as many elements as you want, but once you define it, it's fixed. You can, however, always write over a value. You just can't change one of the values within it, right? So I can say, if I say x equals the tuple whose members are 1 and 2, I can later say x is the tuple whose members are 2 and 3. I just can't say x sub 0 equals 2 and x sub 1 equals 3. So make sure you know that. We talked about modules. Here's actually where we imported our own module in. So lecture 07 has code as well, I think. Let's see if we have code for lecture 07. Yeah, lecture 07 actually shows you how to import, and it has the 3. So lecture 07 extends our area example to include the area of a sphere, and then it shows you how to actually use a module in your own code. So a module you wrote in your own code. So make sure you know that. Okay, and then we talked about images. Images won't be on the test, but they are a good illustration of both modules and tuples. So if you don't understand this, you don't have to worry about things like crop and paste. But if you don't understand what's going on here, you probably, if you don't understand what scaled.show is, if you don't understand what scaled.save is, you don't have to be able to write this, but you should be able to read it and understand pretty much what's going on. So make sure this is a good introduction to modules, and it is a good introduction to functions that change their value. And we saw that in lists. Again, it's not so important for tuples and strings because they're immutable, they can't be changed. But please make sure that you can actually read through this and understand how modules are being used. All right. I think at this point, don't cry. No loops. Yeah. we'll give you enough practice on loops. Trust me, you have two more in semester tests and a final, so we will loop you to death. Well, not really to death. That's that would be bad for enrollment. Um, and yes, so it's on lectures 1 through 7. It's on labs 0 through 2, and it's on homework 1 and 2. And yes, I started recording. I think. Yes, I started recording. You can use SEP. You can use end and SEP. I'm just scrolling down quickly through the questions. So let's take a quick look at SEP. Let me bring this up for a second. What do I want to? What magic notebook do I want to use? Let's use Spider for this one. Okay, so we want to talk about SEP. We want to talk about end and SEP. So when we have a print statement, 3, 7, 9. So this is a print statement. It's going to print out 3 values, 3, 7, and 9. Actually, let me do this over here. Actually, I have to pay attention to what point I'm going to try to make to decide how we're going to do something. Okay, so I'm going to do a print statement. I'm going to do print 3, 7, 9, right? And then I'm going to print we'll just print I think ta-da is 2 words. What do you guys think? Okay? And we're going to use this to illustrate SEP and end. Okay. This first print statement has 3 values, 3, 7, and 9. It has a separator character, the comma, which separates the three values, right? And then after that, when we get to the end of this, after we've printed all 3 values, we've reached the end of the values, and that kind of brings something else into play. And then after that, we're going to print ta-da. So if we run this, what we're going to get over here is we're going to get the values 379 printed on one line, and we're going to get the value ta-da printed on another line. Okay? So now let's start deconstructing this. Well, this comma is the separation character. We can control what character we use to separate. So every time we hit a comma within our values, our value list, our value parameters, we will print out the separation character. So, for example, if we make our separation character, this is a null string, right? Strings have 0 or more characters. There's no characters there. If we make this the null string, what we find out is that this space is no longer printed. Instead, every time we come to a comma, we print the null string, which is nothing. And we can make this whatever we want, right? By default, it's the space, right? So if you do nothing, it's set to a space. When you run that, you get 379 just like we expect. But we can make this whatever we want. I can make it 3 dashes, for example, and we'll have 379, right? So whatever we put in there is what's going to get printed whenever we hit the comma. And notice that this space over here doesn't matter at all. We don't care whether we have that space in or not. That doesn't affect the output. What affects the output is the fact that we've reached the comma and now we've hit our separation value. So we can run this again, and we're going to get exactly the same thing with the 3 dashes. Okay, so that's part of the solution. The other part of it is there's an end parameter, and the end parameter, the end character or the end string, gets printed whenever you reach the end of your values, and you can specify either or both of separator or end. So let's start by, just like we started with the separator, let's set end to the null string. When we do that, what we find out is that now instead of going down to the next line, we stay up on the same line. When we hit the end of our values, when we print out the 9 and go to print the end character is the null character, nothing there, empty string. So when we do that, right, our next print starts where our first print left off. By default, this defaults to the new line character, the /n, right? We run that 379 Tada's on a new line. But again, we can make this whatever we want. We can make this 23 /n, 23 /n. I don't know why 23 came to mind, but we can do whatever we want here. And right now we print out 379, 23, a new end line, and then we print out Tada. Or maybe we'll take off that last one, and now Tada will be on the same line with our 23. Again, this gives us control over what gets printed when we're done printing values. All right. Any questions? Any questions on that?
So how do you use the separate thing for more like complicated print statements? Because I try to use it sometimes, but it's with print statements that have like a lot of concatenation and just commas there, but I usually get an error, so I just wanted to know.
I mean, the easiest thing to say is you do it right. So I'm not sure what I'm not sure what your error is. If you tell me something to type, I can tell you what you did wrong. But there are an infinity of ways to make issues. Like if we wanted to print our Christmas tree example. No, that doesn't work so well. What do you have a specific question in mind or a specific number from the
No, not at the moment.
previous exam? Or if you can come up with an example that I'm happy to go through it with you.
Okay.
But the idea is whatever you put here, the separator character gets printed when you hit here. So you just have to work it until you get them correct. A lot of times what we're going to ask you to do is use it, the most useful ones you can do for either of these is come back to where I want you. The most useful thing you can do with either of these, if you have to pick just one functionality you have memorized, these are the ones you want to memorize, is suppress spaces and suppress line feeds. Right? So this should print everything together all on one line. Okay? So those are the most useful ones. But other than that, you have to construct a string that I don't know. I'm not sure what I don't have an example of what you're asking for. So I'll do it if you give me something to work on. Okay?
Professor Turner.
Yes.
Sid here. Just a quick thing. I think to help with whoever said that, I think sometimes if I use parentheses around the right after the equals, I think that sometimes helps in Spider. I have no idea why, but in end, I didn't use sep before, but I used end, and I feel like sometimes with parentheses it works, and without parentheses it doesn't work. But then sometimes without parentheses it still does work. So I don't know what's the case with that.
Okay. It's probably precedence. Like if you do something like 25 times a space plus, I don't know. You can get it into situations where order of operations kind of bites you, and you can end up with a string that's not good because you end up, I don't know, adding a number to a string as opposed to multiplying, right? So, or something like this where you have to look at this we're adding a string to a number, and you can only add a string to a string. So for a concatenation operation, it has to be two strings. For a replication operator, it has to be a string and an integer. I can help you out if you guys tell me where you're having problems, but if it works, I know it works. So it's a matter of figuring out what was done wrong, and I can't do that without seeing what the issue is. Okay. But yeah, thank you for chipping in there, or helping out. All right. Question is the exam PDF available for download? The encrypted one is. It's in, let me see. Do I have a submittee up here someplace? No, but I can get one. Okay, if you go to submittee.cs.rpi.edu and you log in as you, and you come to computer science, and you go to course materials, right? And you make it all look nice and neat. The encrypted exam is right there. We will publish the encryption key or the decryption key at 6:55. At the same time, we will upload an unencrypted version. So if you have problems decrypting, you can always download the unencrypted version, but nothing is going to be available for you to look at until 6:55. Okay. And we will give you the password, I promise, just not until 6:55. You are responsible for timing yourselves. Please set a timer when you decrypt your file, and please, or if you use the unencrypted version, when you open the file, please set your timer. We are going to try to figure out when you guys start. We will do our best, but you are responsible for timing yourselves. We can't give you time cues. We don't have anything set up to time you remotely. Okay, and I clicked the link and it just opens in browser with the password prompt. That's good. That means I encrypted it correctly. We will publish the password. That will be what you enter into the password prompt area, and then you'll be able to open it. Let's see, what else do we have here? You don't have to print after taking input. We will actually have the ability to run these on submittee. We won't run them during the test because we one, don't want to impact bandwidth for the uploads, and two, we don't want to accidentally release answers to you. So we won't be running it during the test. We do have the ability to run it afterwards just so we can check your answers. If you print it, it'll make it a little easier for us, but it is not required. You can do it or not at your own preference. Yeah, I think that's pretty covered. No comments are required. Again, if you are trying to do something and you're not sure how to do it, or you're having significant problems, at least telling us what you're trying to do will allow us to go through and assign points to the rest of the answer, right? So if you tell me I'm trying to add 7 to a number and you don't know how to do it, but if you added 7 to the number, the rest of your code would be right. You will lose points for not being able to add 7 to a number. But I may be generous on the rest of it because I know that the value that's intended in your variable or whatever is 7 more than the original number, right? So the comments are not required. If you put them in, that's one of the ways that you can tell us. I think we mentioned that. Tell us the assumptions you make. If you tell us assumptions you're making, please put them in comments. That'll allow us to go through and at least give some partial credit when we can. Yeah, the password will be published to the discussion forum.
I had a question about tuples.
Sure.
Yeah. So, are tuples, is that just like when a variable saves a list of 2 values, like when you assign a variable 2 values?
So 2 values is an oversimplification. You can have as many values as you want. So for example, let's come back up into here. If I wanted, I'm going to kill this. I can probably reconstruct that if I need to. So a tuple is, I'll call it tup, is any number of values. So 3, 4, 5, 6, 7, 8, 13,905,893. And it can also be strings, and it can also be floats, 34.5, and it can also hold other tuples. Okay, and we can actually print that out, I think. Right, so that's what a tuple is. And, so it can be any number of characters, or any number of values. And you can access, having defined it down here, we now have it defined, or having run it, we now have it defined, and we can look at the various values that are there, right? Tup sub 0 is 3, tup sub 2, 5, 7, I think. 7 is the string hello. Tup sub 9 is itself a tuple. Tuple sub 9 sub 0 is the 3. Tuple sub 9 sub 1 is the 4, right? So, a tuple is a way of aggregating values together. It can be any number of values. The types can be intermixed. It doesn't have to be all the same type. We can access each one of those individually, but we can't assign back into it because it's immutable. Does that answer your question, or no?
So is a tuple just like a list of values?
Yeah, it's
Yeah,
well. See, a list is a list of values. A tuple is a tuple of values. The semantics are slightly different. A tuple can't be changed, but yeah, other than that, yeah, that's pretty much it.
Can a tuple, you can't append a tuple?
Nope.
Oh, okay, I see.
Now let me having said that, let me show you something though. Right, we can do something like tup plus equals 5 4. Nope. 95 4. Okay, and that looks like it appended to the tuple, right? But what it did was it created a new tuple. It's the same as this statement. Okay, and what this does is it creates an absolutely new tuple here, right? That looks like you appended, but you didn't. You created a new tuple and then assigned it back into the new value. So you lose. So we could do something like x equals tup plus 9 4, and then let's do this. Right, so we can have a tuple, and I'm going to do a much shorter one this time because I'm lazy. 3 4 5. Hello. Okay, so that creates a tuple, and the tuple has a value associated with it out in memory. We can do something like x equals tup plus 5.1, and then let's just leave it at that. Right? Yeah. Okay. Tuples of single values, you need to indicate that it's a tuple with a comma. So sorry about that. If I put in values here, that would be a little easier to kind of understand. Right. So now we have two tuples, tup and x looks like adding on to the end of it looks like we appended, but we didn't. What we did was we created an absolutely new tuple out in memory, and then we can do tup equals x. And what that does is it makes them both refer to the same new tuple that we created, and the old tuple's kind of thrown away. So this is the same as with the concatenation operator on strings, right? You can concatenate onto strings, but it doesn't change the original string. What it does is it creates a new string. So if we do something like this, this maybe shows it better. Right, so now, if we start at the beginning, we start off by creating a tuple with 3, 4, 5, hello. We assign that to x, so now x and tup both refer to the same tuple. And now, when we append onto tuple, we don't append onto the tuple, we just create a new tuple and make tup refer to that instead. Okay, does that kind of make sense? Does that answer your question?
Yeah, that does answer the question.
Good.
And yeah.
Professor Turner?
Yeah.
Are tuples in parentheses and then lists in the square brackets?
You guys are asking simple questions with less than simple answers sometimes. Yes. So if you print out a tuple, for example, let's come up into here and print out a tuple. Right? It'll always print it out with the parentheses, and then lists would have a square bracket. The issue with tuples is, though, I can do something like T2 equals 3, 4, 5. And T2 is a tuple. Okay, so when I'm defining it, if it's not ambiguous, I don't need the parentheses. If it's not unambiguous, like I'm passing it into a function, def p of tup, right? I can do p of t2, and that'll print t2, right, which is a tuple. I can also do p of nine, 13. And notice I have the parentheses around them this time. Right, I didn't need the parentheses on this line, but down here I need the parentheses. Because if I don't have the parentheses, it thinks that these are two separate parameters. So you are always safe if you put parentheses around tuples, but when you're reading code, there are going to be times when you read it and the tuple is implied by the fact that they're all on a line with a comma. Okay?
Okay, that's good.
Yes, sorry about that. I know that's more complicated than you were actually asking, but I just wanted to make sure I gave you a correct answer that hopefully didn't confuse you more. All right.
Professor, I apologize if this has already been answered, but will the password for the exam be posted on Submity or some other platform?
We're going to post it in the discussion forum at 6:55.
Okay, thank you.
And I'll put it on broadcast, so you should get it in your emails as well. Okay. You should know how to import from other files. Yes. Let's see. I think that's in, by the way, importing from other functions, I think is in lesson 4, although it could be in lesson lecture 5. You can use sep and end. It's expected. You can't use lists. In fact, I don't think you can use loops either. Let's see. If you guys have questions, speak up. Otherwise, I am just paging down through here.
Can you go over the importing like functions and like files and functions from other files?
Sure.
Thank you.
So Python is infinitely extensible. And they did that by making it really easy to create modules. So don't get too hung up on this stuff. Okay. It's easy to make this much more complicated than it is. Okay. So we can start off, let's say I want to create a module. I don't know. Let's see. I'm blanking on what I want my module to do. I've been doing printers. So let's do a module, and I'm going to call it printer. And you put anything you want in your module. So we can put out, in general, we would put module description here. Goes here. And again, we're not going to grade you on comments and program structure, but I may as well not be a complete slob about it. And then you have your functions, and you can have as many as you want, and you define your functions, and you can even define variables here as well. So I can say right, and then I can say our printer function is going to take a string f or something that we want to print out. Turns out that it's probably a little bit more flexible than that, and it's going to print f, and it's going to print f with the separator equal to our separator character. Spelled correctly, I hope. Yes. Okay. And maybe we even want to have an end character here. And we will go down to the next line, print doobie-doo, so for Scooby-Dooby-Doo. All right, so this is our module. I'm going to save this out as, I don't know, printer, right? So I'll save this out as printer. .py. py, and I'm actually going to save it in the class directory. Okay, so you can see now up here, I'm in the class directory, right? And I'm doing printer.py. I can now create another file, and I can save this as use printer. Come on, where are you? And you notice that I'm again saving it into the class file, so it's all going in the same place. For what we're trying to do, we're going to generally assume that it's not required, but it does make life a lot easier, and it's how we would have to do it on SMIDI anyway. So now I have use printer, and I can do import. Right, I want to import my print function. So to import the print function, we would say import printer. Right, printer is right here. That's our file. And actually, let me put a And that is not spelled correctly. You guys probably don't care. Maybe you care. I think that's close. All right. So I'm going to save this. Right. So we can come in here. We can say import printer. Since it's in the same, we have it in the same directory. So we just do import printer. Notice it's the name of the file with the .py. And then we can say printer dot I'm going to change the name of this. I'm going to make this print func. Just so that you guys don't get confused when we look at this later. So now we say printer.print func. What?
Does your other file have to be open in the same
No.
Oh.
It has to be saved in the same directory. Right? So I can
okay.
I can put that
Okay,
away.
I see.
Right? So it's no longer the only file I have.
Professor Turner, just for a quick question about this file creating. So basically, when you create like a class file and you, a function file, and you add some define some variables inside that function file. So is the variable you define in the function file global, or it's only partial variable? So basically, can you change the variables after?
Yep. Let me
input that file.
Yeah, let's take a look here. Okay. Let's see if this runs. Okay. So now I'm going to open it. I noticed that I put away that file. I did that so you guys could see that you don't have to have that open. We can come in here and we can look at printer.py so that I can remember what I called everything. Ending was the other one. So we can print out okay. Right, so we can do this. Right, we're going to import printer. Once we import printer, we have access to all the variables and the functions just by putting our module name printer in front of it, right? So I can call it using printer.separator or printer.ending and go back and review the different ways of importing. This is the way I like to import. I think it's the best way to import, so I'm going to stress this one, but there are other ways to import things that give you different kind of behavior on these module names. But this is a good way to do it because now we have everything kind of cascaded. And we run this, we get, we print out the separator, which is, and I should do something like print done, just so you can see how far down we go. All right, so we print out the separator, which is Scooby-Doo. We print out the ending, which is Doobie-Doo, and there's a space. There's a in Doobie-Doo, right? There is a /n, right? So this is the /n right here. There's Doobie-Doo, and then there's another /n. So we're printing out Scooby-Doo, we're printing out Doobie-Doo, and then we print out Velma. Why did that not work? Oh, because FG. To show the separator, I actually need two values here. So we'll do F and G, and then we'll do sep equals separator, and I forgot to put the ending in, and end equals ending. All right, now we have something. Okay. We'll try this again. We run this again, and we have to do Velma and Shaggy. Okay, my print function now takes two variables. Okay, so when we run this, we go down. This is the separator. These three lines are the ending. And then when we print, right, we're printing out our first value, which would be Velma. We're printing out the separator, Scooby-Doo. Notice there's no spaces. And then we're printing out our second parameter, G, which would be Shaggy. And then once we've done that, we print out our end, which is a new line, Dooby-Doo, and then a new line. And then, of course, just to show you where everything ends, I'm printing out the done. Okay, so that's kind of how separators work. That's using separators in a module. So that's kind of how modules work. Now, the other question we had was, can you redefine those variables? So let's try that. We will say printer.separator equals snack for a Scooby snack. And we will make printer.end, we'll just make that equal the empty string. And then we'll just try this again. And maybe I'll print here, print start. Okay, just to kind of show us. And what we'll find out is that, right, this is the first one before we change the separator and back. Works exactly the way the previous one worked, right? And then start is after we changed separator and end, and our change actually comes in oops. Our change actually comes in, and we no longer print out, we no longer print out Dooby-Doo after our line. Okay, so yes, you have full access to the variables. You can change them. You can change the value of pi. They tried that in Indiana. They tried to change it to 3, I think, before a mathematician got involved. That was a state legislature kind of thing. All right, does that make sense? All right.
Why would they try to change the value of pi?
Because it's Indiana, bro.
Somebody came in and told them how hard it was to calculate things using pi being 3.14159, on and on and on, and said, look, it's only a little bit different. So if we just make it 3, we will say, if we legislatively define it to be 3, we will save a lot of money in our engineering budget, because anybody can multiply by 3. And then they were about to actually pass it when a mathematician found out that they were doing it. And he actually attended the session and explained that you couldn't arbitrarily define what pi was, that it was actually a relationship that holds throughout time, regardless of what the Indiana state legislature might want to do. So it's kind of a funny, I think it was Indiana. It's kind of a funny chapter in the history of pi. We covered the sum function. Sum is valid. Oh, I'm sorry. We covered the sum function in lists. So I don't think it is valid now that I'm thinking about it. Although I think you can actually do a sum on a tuple. No. Okay, good. Oh, no, wait a minute. That's not a tuple, that's 5 arguments. We can make this a tuple. Now it's a tuple. Yeah, okay, so so if you were to use sum on a tuple, we would be okay. If you use sum on a list, not so much. All right. I have a question on late assignments. Late days do not affect the credit you can get. So if you submit late and you have a late day, you submit within the 2 days you're allowed to use, and you have enough late days available, then there's no issues. Okay, sep. Is sep similar to strip? Let's talk about strip. It's not actually similar to strip, but strip has its own kind of neat behaviors. If you have a string, let's say we have a S equals some white space, some stuff, some more white space, could include some tabs, could include some new lines, some more spaces. Okay, S will look something like that. You can see that we have tabs and new lines and white spaces. S.strip will remove all white spaces from the outside on both sides of the string. And strip without any parameters removes all white spaces. It doesn't care whether it's a tab or a new line or a space, right? It'll just get rid of them. And then L-strip does it from one side, the left side, and R-strip does it from the other side. You can also use strip with parameters. So if we do A equals, I think we used abracadabra. Right? And if you do A.strip, well, there's no white space, so it won't remove anything. If you do A.strip A, it'll take off the A's from both the front and the back. You know, L-strip will go from the left, the front, and R-strip will go just from the back. And notice that, by the way, these aren't changing A, right? None of our string operators change our strings. They just return a new string. If we wanted to use them, we would either have to cascade them, waterfall them, or assign them to a variable. So if we wanted to do A upper, right, that would strip A's from the right side and then make everything uppercase. Interesting thing about strip, I'm going to go back to a regular strip. If you strip, for example, ABR, what that'll do is it'll take out all of the A, B's, and R's until it gets to something that's not an A, B, or R. Right? So we stop at the C there. We stop at the D there. And this is independent of the order, right? You don't have to have these in order. It just takes, if any of these characters are on the outside, it strips them off till it gets done. And that just leaves us with CAD. All right, next question. Let's see. I'm going to keep going down through this list, but you guys can feel free to ask. Let's see.
Can you also use replace? I know something like you could do string that replace one thing like space and whatever you want to replace it with.
So you can do a replace, right? It doesn't work the same as strip, right? They're two different functions. Strip comes in from the outside, and as soon as it sees something that's not in the list, it stops. Replace goes through the entire string, and it has to exactly match, including order. So if we do A dot replace ABR with, let's replace it with star, just for the heck of it, right? We're replacing here. We're replacing here. Right? Those are the substrings that have A. We're not replacing these A's. Yeah. Okay. And if we were to do just, for example, A, right, it wouldn't just stop at the outside. It would continue on through the entire string.
Yeah.
Okay. But order matters with this. So AB, if it's ABR, it will only replace ABR, that exact sequence. Okay, go ahead.
So strip can't strip the A in the middle, right? Just strip the A in the front and
right.
Okay.
Yeah, you can't strip something from the middle. You can replace something in the middle, but you can't strip it.
Wait. But isn't there also a function that strips all the spaces in a string, like all of them?
That does what?
Strips all the spaces in a, like, removes all the spaces in the string.
Well, I mean, you can do. a replace to I mean a dot replace will. A strip will take it from the outside. L strip will go just from the left. R strip will go from the right. But replace will replace all of them if you want. Is that what you're talking about? I'm not. Like if we have B, right, a string with a lot of spaces in it, what we may want to do is B dot replace a single space with, well, nothing, an empty string, and that'll remove it. That would be the way that I would approach that. Is that what you're looking for, or not?
No, isn't there a function called like s strip or something like that?
I don't know. I've never used it. S strip.
Oh, okay. Never mind then.
Yeah, I'm not aware of it. If there is, you're welcome to use it. We'll look it up. But I haven't used it. If you look at the string functions, there are a lot of string functions, so it's not all that all that unusual for me not to know everything in one of these classes. But all right.
Professor, could we do like one example with the dot find function?
Sure. And I have a question here on. I'll do the dot find, and then there's a question on the difference between a return and a print statement. Is that still salient, or do you guys understand that now? Because I'll do the find, and then I'll do that, if that's okay. Let's see. We have an A, abracadabra. That's a good one. Okay, so we can do a dot find. Right, and then we tell it what we want to find. Well, yeah, we'll start out just by telling it what we want to find. Right, so if we want to find A, this is going to return the index of the first occurrence with A. By the way, there's an A dot count that'll tell you how many of them there are as well. There's an A dot count spelled with U's and N's and O's as opposed to characters one to the right of them. All right, so that'll tell you how many A's there are. So if you want to get rid of, or if you want to find the locations of those, what you can do is, a dot find A returns a 0, right? And that's the index of the first A in the string, right? We can also give it a starting and ending location. So we can say a dot find A, and let's say we want to start at position, well, if we start at position 0, we get our 0. If we start at position 1, it's going to start at this point of the string, and it's going to walk through until it hits the next A. So this would be 0, 1. We're going to ignore this one because it's after the 1. 1, 2, so it should return a 3. I hope. Yes. Right? And now if we go A starting at position 4, since we know there's 1 at position 3, we'll find it's 5. We can look at position 6. That'll tell us there's 1 at position 7. And if we look at position 8, that'll tell us there's 1 at position 10. And now if we look at position 11, starting at position 11, it will tell us that there is no A in position 11. So let's look at this. It says 0, 3, 5, 7, 10. And if we look up at our A, right, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then if we try looking beyond that, there are no other letters in the word, so it's not found anymore, and it returns a -1. Okay?
Thank you.
You're welcome. Do you guys need me to go over the difference between print and return in a function?
Hi, Professor. I have a question for this part.
Yes.
Hold on. Let me do this one first. and then I'll come back to the next set of it. Okay, so let's go back to our printer function. Okay, so our print func does a print, right? It doesn't return anything. So the implicit return value from this function should be none. So if we use, so let's see, I'm going to do a re-import. I don't know if this will work or not because there is some caching that's involved. Yeah, no. Now it'll work, I think. Okay, yeah, so it worked. All right, so we have we've done our import and we have our printer. So now we're just going to kind of focus on the mechanics of what we're doing. Our print function doesn't have a return statement. So we can call print function right? And it does the printing. Right? It prints out A, Scooby, do, and then our B, and then our blank line, dooby doo, blank line. Okay? So you know, in this case, we call the function does something such as print, but it doesn't actually return a value. So if we do something like, let's pull this back up, we do a printer subprint function, right? In order to execute this print, it's going to go through and call printer print function, which should print out our string, and then it's going to print whatever printer.print function returns, right? Well, this is our initial printout. This is from print function, right? That matches this. And then after we're done executing this function, what we've done is we've returned to our calling program, to our calling level, and we're hitting the print again. And what we're printing is not this string that print function printed out. This print is completely unnecessary, right? We've already printed that string out. Instead, what we're doing is we're printing out the return value from this function. And this function doesn't have a return value. So a function that doesn't have a return value returns none. Okay? Maybe we want to have a return. Maybe we want our return to be nothing. We'll have a return statement, but we're not going to return a value. So if we try that again, we'll import printer, and we'll do the print function again. Well, we're still getting the none because we have a return statement, but we don't have a return value. And now we can also add this, and we can say 5. Right? And now, if we run this one more time, what we'll get, now we're actually returning a value. This return value is what gets replaced into this function after the function call completes. Right? So this should print out all this stuff, but then instead of none, it should print out 5. Okay? So that's kind of one way through this. Now, sometimes we ask you to print from the main and use a return statement. So let's just look at that for a second before we go on. How do I want to do this? I'm going to say string equals and we're going to put in our F and G in there in the appropriate places. So what do we want to do? Well, we want to put in our F, and then we want to put our separator. So let's make another one. And then we want to put our G, and then we want to put our ending. And then let's extend our format call F running out of space here. I wonder if that'll work. Nope. Separator, G, ending. Okay, so now we're creating a string that is, exactly what we printed out before, exactly what this print statement was doing, right? We have F here. In the next format holder, we have the separator, right, which would come in right here. And then we have, in the next one, we have G, and then the final one, we have the ending. So this is exactly the string we had before that we were printing out, but now instead of doing that, we want to print this from our main program, so we need to return string. So now we've calculated a value, and we want to return that value from our function into our calling program. And I think if I do this, I didn't prep this because I had no idea we would be in this place right now. But why is there a 5? I don't think that imported. I actually have to save this. Okay. There we go. Right. So now instead of, we're no longer returning the value 5. Instead, we're returning a string that is this. We can take the print out and look at that. Or actually, let's assign this to a variable. Right? So we're actually returning this string. This is the string we're building. Okay, so that kind of clear that up a little bit, I hope. All right, we are at about 3:50. Class is officially over. You guys, well, actually, this was always a voluntary attendance anyway. I'll stick around for at least a few more minutes. At least I can go for at least another half hour if there are more questions. But you guys have sat here being patient long enough.
Like extra credit, let me see. I don't
sorry?
even know what that is.
Go ahead.
Professor Turner, how would you describe the parameters? Like on the practice question, on the example in the exam one, you said like describe parameters or tell what the parameters are. Okay. How would you write that?
How would I write that? So the parameters to a function are essentially variables local to the function. They don't exist outside the function, that are initialized with the value of the arguments given when the function is called.
Could you do like a quick example?
Sure. Well, yeah, we have one here. For print function here. Oh, you know what? For that question, by the way, we weren't asking for anything philosophical. We wanted you to look at that specific function call and say like A is a parameter and B is a parameter and C and D are arguments. So that wasn't. You took me off. You took me off guard. That isn't. I don't think that was a philosophical question. That was a just point to them in the thing. But let's take a look at this. So we have our function here. We have our print function, right? And it doesn't matter that it's in a module. A function's a function, and this is the function name. It has two parameters, f and g. F and g are the parameters. When we call it down here, we call it with arguments a and b, string a and string b. So a and b, the strings a and b, are arguments. The parameters f and g are parameters. The string a the first argument gets put into parameter f, and the string b, the second argument, gets put into the second parameter g. Okay? Is that?
Yeah, I get it now. Thank
Yeah,
you.
it's just a mapping. You know, what you can think of, one of the ways to think about this is this is essentially, you know, before you get into your function, it's saying, you know, f equals a, right, if the argument's a. And then you can use, down inside your function, you can use f and g. But they disappear once you get out of your function. So you got to use them and then either return something or they go away. All right.
I have a question.
Sure.
I remember for one of the examples, we used the dev function, but we didn't have a return statement. When would you ever need to really do that?
Here, I mean, well, okay, so there's, if you're talking about,
Or you have an if statement with no else, like things like that.
okay, so those are two different questions. So if you have a function without a return, one of the reasons you would want that is there's a side effect of the function that you want to occur, but there's no value that you need afterward, right? So when we had this print function just printing out something as opposed to returning a string, if all I wanted it to do was print out something, not having a return makes sense, right? Because it's what I'm looking for is the side effect, not the value. The side effect is actually printing out the value. As we get more into modules, you'll find out that in an object-oriented design, sometimes the side effect is modifying the internal state of the object. Okay, so there are valid reasons for not having a return on a function. You know, for us right now, it's mainly if we want to print something, if we want to encapsulate all of our print statements in a single function, so we don't have to mess with them over and over again.
I see.
And if else is, you know, let's say we have an error. We do this all the time with so let's say we have I don't know. I'm running out of ideas, man. The hardest part is making up the stuff that doesn't sound too cuckoo. Okay, we'll have a function def big, and we'll give it a value g, and g is going to be some numeric, and we want to say if g is greater than 1000, print wow, that's big. Right, now maybe we have something else we want to do in our big, like maybe we want to return maybe we want to return bigger, where bigger is and yeah, I know what I'm doing wrong. Okay.
Bigger.
Yeah, I'm getting a little annoyed with my autocorrect. I'm making my autocorrect is making more mistakes for me than I'm making. There we go. This should be G, not bigger, not big. Okay, that should be good. Okay, so this is an example. Like maybe if it's above 1000, we need to warn the guy that this is getting pretty big. You might want to start considering, but it's not an error. You know, it's just something. By the way, we could do it. Could do an error code in here. Oh, actually, that's a good one. Let's say if G is above 1000, we're going to print out that's big, and then we're going to do a return G. We're not going to make it any bigger. Okay, so that was my fault. So if we do that, right now we have this function. I hope big.
What?
I said I hope I have function big defined. I thought that was the file I executed, but that looked weird. So we can do big 2, and we should print out 4, right? We can do big 4, we should print out 16. We can do big 16, and it'll go up to 256. So we have this function big, and what it's supposed to do is it's supposed to print out, it's supposed to return, big squared, our parameter squared, up until it gets to 1,000. Right, so 999, it should work. And then we get to 1,000. Well, 1,000's as big as we want to go. So now we have an if statement without an else, because greater than 1,000. 1,001. Wow, that's big. So we have an if statement without an else, because we only want to do this when we hit some condition that causes a change in our function. Our function is no longer doing what we want it to do. And these come up all the time. A lot of these come up in error checking inputs, or if we're in loops. And when we learn how to use breaks and continues, a lot of these will be breaks and continues, where you're trying to stop the execution of a loop or stop the current iteration of a loop. So the else clauses just simply do everything else. Okay.
Well, thank God loops aren't on this.
Yeah, I feel the same way.
So, Professor.
Yes.
For that example, are you only returning the G? You're not going to return the bigger for like 1001?
Yes. Yep. The first return is the only one that counts. Once you hit return, you've left the building, left the function.
Okay, thanks.
Elvis no longer lives here. Okay. Good question. You guys are actually giving me some very good questions today. If I've had to stop and think the right way to say this a couple of times, to try to extend the notes as opposed to just parroting what's in them. Yes, the password should be released as soon as 6:55 hits. Of course, this was an hour ago these questions were asked. You have 90 minutes. I don't know how long it's going to take for the average student. Our hope is that it takes 80 minutes for the average student and 85 minutes for the really good, really fast ones, because we want to make the fast ones have to think a little bit. But our target is 90 minutes. But remember that we do curve. We do curve the grades. So if you're having problems, we will look at. I never curve down. So if the average comes out higher than we want it, it stays higher than we want it. If it comes out lower than we want it, we will kind of boost it up to be a little bit closer. And this is my first time giving this particular format of a test. We've always had a lot more questions with different types of variety, but it's kind of hard to do that. We can't give you what's the output type of questions because you have a interpreter sitting right there. So it makes it different. Hopefully it will be good. So there's always questions about formats. And what happens if you miss things. If you miss if there are minor typos that are not germane to the problem, germane means they aren't directly impacting the answer we're looking for. We tend to be fairly forgiving on those. Generally, it's a point off or a couple of points if you do it repeatedly and it's significant, or 0 points if it's not repeated or significant or something like that. We try to be kind of gentle on that. But if we're asking you something and you have a minor typo that it greatly impacts the part of the question we're asking about, then we have to take more points off. So be careful. Don't worry about, I think I answered this in the forum. Just look at some of the examples I give there for things that are germane and not germane. I think I use the frame box as an example. If you have an extra blank line, or if you have an extra blank line in there, that's important. That's part of what we're trying to part of the significant part of the question. If you have a misspelling in your prompt, that's something completely different. They shouldn't. Our goal was to make this doable in 90 minutes. So if you took 8 hours for your homework problems, hopefully it's easier than that. Go ahead.
Professor Turner.
Mhm.
So I was just watching. I didn't attend your lecture this Monday just because I had something going on. But what's the specific part you recommend me watching to know where where to know how to do the test? Is it like the whole video you go through it, or is it like part 2, part 3?
So it should be the part 1, right? We go over, or I think it was part 1. Yeah, it's where we go over. You know, you'll recognize it when you see it. We went pretty good through what you'll need to do. I think it's part 1.
Okay, and then are TAs open till what time are they there until? Are they there until like 6:30, 6:50? Like, well, what if we can't access? Who's the best person to contact?
If you can't access, it's right in this. It's right in the study stuff. If you have any problems, email cs1instructors@cs.lists.rpi.edu.
cs.lists@rpi.edu.
CS1 instructors. It's right in. Hold on. Don't type this in. All right, go to the T1 overview. If you have any issues, hit that. Right.
Okay,
any
and
issues
then
you have, hit that. Okay.
okay, and can we use an interpreter to help us, or should this be done independent of an interpreter?
Now we're assuming you have your interpreter available.
Okay, thank you.
Sure.
Professor, I have a question. So if we looked over those like longer form coding questions from like T1 overview and the 2017 exam, are we expecting like a similar format to what we're going to get on the exam today, just like 4 questions or whatever it is? Or
I would
like,
yeah, I mean, I would expect that would be the types of. I would look over the entire test because those topics, are important regardless, and how we ask them, maybe different. But yeah, I would look over the long form questions.
because that's what I've been looking over. Like I did those questions last night and stuff like that.
Okay, good.
So okay, so like especially something like in that terms like length, like code length, something similar to that, like or something like.
You can
You know what I
expect
mean?
it maybe so we've cut down the size of the exam, so you can expect there are fewer questions, so you can expect that the questions may be a little longer.
Okay.
But it shouldn't be, it shouldn't be
Like leaps and bounds more difficult.
Right.
Okay. Got it.
I have a question with the format of some of the questions in the T1 exercise. So in exercise 7, it says to write a Python code that reads a string and then reads an integer. Are we supposed to assume that that just means like input?
Yeah.
All right. Thanks.
Sure.
Professor.
Mm-hmm.
So about the in the practice exam, there's some questions just asking about the concepts and what are the parameters and stuff about a given program code. So like how do you submit the answer for that on submitting, or you are just typing it?
Like I said, this is going to be much more like the long form questions than the short form questions.
So there will be
constraints of the online. It's going to be a lot closer to your homeworks, to the homework format than to the initial questions in the exam from the spring.
Okay? Are we going to take screenshots of our code?
Are you going to submit your code?
Oh, okay. Cool.
Oh, and about submitting the code. So basically, if you submit a code, and then so how are you gonna check the code to see whether it's a full credit code or not? Like for example, if I use something like maybe I accidentally use a list or something inside the code, is that also good? Since if I can get a correct output every time.
So this is going to be a little bit different from how your homeworks were graded. You won't get any feedback to begin with, right? You won't know how well you did. We will have we will run the auto grader. Maybe actually we haven't actually decided on that yet. In general, we my concept is we'll run and see what you get, because that'll give us clues where to look for issues. But it will be completely looked at by and graded. You know, there's no auto grading points, so the TA will give you your full grade, or instructor will give you your full grade. So you know, if we tell you not to use lists, don't use lists, because we will catch it, and there'll be a rubric item that says they use lists. We will.
So basically, I'm sorry.
We will run the code. We will probably run the code, just to see what your output is. But that won't be that'll be something we look at, but not dispositive of a.
Wait, but can we use like, because for all my homeworks I use the format list because it's easier to format like long things. Are we not allowed to use the format list?
So don't use format lists on your homeworks.
Okay.
Because it will crash. If we're looking for something in particular, it will crash the Submiti browser. I think we mentioned that in some of the notes.
Wait. I didn't know you're not allowed to use format list.
There's a posting to the discussion forum. It will crash static analysis. It doesn't crash the program, but it crashes the static analysis. So if we're looking for something specific in your code to make sure that you're using a list or you're using a function, it'll crash that part of it. Okay. So if you've had problems with that part, that's what's happening, and it is answered in the discussion forum a couple of times.
I didn't. Oh, okay. I need to look at that.
So try not to use those. We did teach you how to use the format statement. The format statement works. Submiti has its own parser. They have to write their own parser, so they lag the standard a little bit. And right now, that won't work. It will run, and it's likely that we will. You know, we haven't actually discussed what we do with format lists on the tests. It's likely we would allow those, but you know, quite honestly, we're teaching you format statements for a reason. So learn them and use them.
For format statements without format list, would you just do the same thing, except instead of putting format list, you would just put your like whatever was in the list in the brackets?
I'm sorry. You can use the dot format statement, right? You were talking about an F string, right? F double quote.
No, like I was talking about like when you do like dot format, right?
Okay, no, that's fine. Those are perfect. You can use those fine. Those are that's what we're trying to teach you. There's another thing called a format string that I shouldn't have said anything about because they cause problems.
I tried to use that.
Yeah.
I tried to use that in the first few assignments, and it's always crash with errors reporting. So that is annoying.
Yes, tell me about it.
Because I didn't read the like all the responses on the discussion, so I don't know like somebody has this problem. I thought it's that somebody just don't want me to use that, but like there's just always error messages popping up, even though your output is all correct. It's just giving an error.
They're in two separate phases. So first we run the program, and then we analyze the program. And it's giving the error message in the analysis phase. So your program will run, it will give the correct answer, or can give the correct answer if you did it right. But it crashes the analysis, so we can't tell whether you use the right number of ifs or the right number of else. Or
yeah,
like
it just cannot count.
Yeah, so it's the it's the analysis of the program structure that's failing. And like I said, it's because they have to parse the entire Python language in Submiti to do that, and they tend to lag a little bit the standard because the standard comes out and then they have to code to meet it. So right now they're running earlier. Okay.
I was talking about this thing like that I posted in chat where it's like format list equals whatever the thing is, and then when you write your function, you just do, or when you write your print statement, you just do dot format, and inside you put format list.
That should be fine.
Which is your variable. Oh, okay.
I was thinking. I thought you meant F strings. F strings.
No, I don't know what that is.
Yeah. Okay. Good. Keep it that way. We'll be fine in CS1. You can learn it for CS2 or any time after this.
We are not gonna learn that in the further courses.
F strings.
I mean in CS1.
We're not gonna learn F strings, no, because they crash so many. And there's alternate ways of doing it.
True.
I will tell you that you will not learn everything in Python from this course. This would be a much longer course, and we would have to do a lot more stuff. You'll learn a lot, but you're not going to learn absolutely everything in Python. I mean, we haven't even learned all the string functions. that would be a daunting task.
Yeah.
So I have a question about strings. So when you're comparing two strings and you're not using a length function, you're comparing the ASCII values of the string, or are you comparing the lengths of each string?
So it's just like a dictionary, right? You look at the first letter, but instead of looking at A, B, C, D, you look at the ASCII value of the first letter, and then if that matches, then you look at the ASCII value of the second letter. So it is the same as alphabetical ordering, like you would in just a regular Webster's dictionary.
And that determines.
But
okay.
just capitals. All the capitals come before any of the lowercase.
All right. Thanks.
Okay. Yep.
Professor, I have a question about the test.
Sure. That's what we're here for.
Will there be like an expected output for all four of the questions, like the homework, or
no? We're not gonna give you any clues as to whether. If you look at the homeworks, we generally show you some examples of it being run, but there won't be anything. You won't get any feedback on Submini at all.
No, yeah, I mean like those examples that you give for the homework.
Yeah.
Will those be given on the test as well?
In general, I mean, it depends on how well we can explain. I mean, if you look at like question 7 up here on the overview. Why am I not showing that?
Where is it?
Give me a second. Yeah, if you look at question 7 up here, right, you could expect something along this line, like right.
Yeah, like that.
Yeah, I mean, these are examples of questions that either are from past exams or were considered for inclusion on past exams and didn't make it. So you can expect that in general, these will be relatively consistent. Okay.
Right, and they'll be like mostly on all the questions.
I'm sorry.
Well, and they'll be on most of the questions, right? I believe, or.
I mean, yeah, they'll be something like this.
Okay, thank you.
Okay.
Well, a similar question about this. So basically, because in the homework it's auto graded, so basically it's very strict on like your output. You need to match exactly as the required output is given. For example, homework, there's several lines of text you need to output, and maybe the line space. For example, you have a empty line between like the print or the output of text, because you need to check your print statements inside. So does that sort kind of things will happen also in the exam?
Yeah, I'm looking for the exact answer I gave to this. Is it here? Yeah, so if you look at thread 179, right, that kind of lays it out. So if you have something like, if we ask you for this and you do something like this, we're probably not going to take off points. If we do, it'll be relatively small. It'll be very small. If, however, we ask you something like this and you give it something like this, you're making a mistake that's germane to what we're actually asking you to do. You've included extra lines in something that we're not expecting an extra line in. So this is going to result in the second one is going to result in voiced.
Yeah.
On
Get
the other
it.
hand, yeah, okay. And then up here, if you remember when you're running in Spider, before every input command, there'll be an extra blank line. Don't worry about those. Those are we understand that that's an artifact of Spider, and they won't even show up in Submini. So if you're getting
Yeah, that is the thing I'm considering about. So basically, sometimes your output text has like different line space between the input you printed out and
that's beyond your control. Actually, you won't have that when you put it in Submini, because Submini's running it, the console in Spider has two problems that I'm aware of. One, it has the tab stop set to one space, so it's hard to show examples of tabs in lecture because it doesn't tab over. And the other thing it has is that it inserts a blank line before every input statement. I don't know why it does that. I haven't been able to figure out how to suppress it. But those are the two things that you can that don't show up well in Spider. Okay.
Gotcha.
All right. Anything else?
Quick question.
Sure.
Even if it doesn't match what somebody is expecting of us, if we print the value, let's say enter integer, I think that's entered integer 1. If we after that type print int 1, will it remove points?
I'm sorry. If you do it like enter integer 1, oh no, we won't. No. And that's one of the things that I think is should be answered in the T1 overview as well. That extra print is something we put in so that you guys can help debug your own code on Submiti. It's not, we won't deduct for it whether it's missing or there. We'll accept either one.
I had a question. How do we format dot format? How do we format integers? Because I know how to format float, but not with integers. Would you just say like 0 at the end?
Now, so for integers, it's actually so in general. So I'm going to give you a couple of answers. So in general, if you just want the default and you just want to put it into place, you can just use the curly brackets with nothing else. Okay, so that'll work. Right, so these empty curly braces say for the current data type, just give me the default behavior. And it works for any data type. Okay, if you do a float in there, it will do right? It'll do the default. If you want to control an integer, then it's :D. Okay, but :D is essentially the default unless you throw in something like a number in front of the D. And then what it does is it takes this entire number and makes it fit within a 10-character space. So D is the format code for an integer. If you put a number in front of it, it's a way to let you line up things. Like, so we can do that first one, and then we can do, right? And they both line up along this right edge, right? So so that's a way you can control the spacing for that. I wouldn't expect that we would ask you to do too much formatting in this. We didn't go into this a whole lot. We will force you to do this on your homeworks first, soon. But that's the actual format for an integer, and then for a string, again, you can just use the empty ones for the default format. Right, or you can use S, I think it is. And I never tried this. I should have tried this. Ah, neat. But it left justifies. Cool. Yeah, so you can do that too. All right. All right. Anything else?
Are we allowed to use Submiti?
You'll have to use Submiti.
Or I'm sorry, I meant Spider. Are we allowed to use Spider?
You can use Spider.
Okay, thanks.
Okay, you're welcome.
So basically, all work can either be shown like within the test, like of the PDF that we got, or within Submittee, and both needs to be submitted, or just Submittee.
No,
It's
you
all
will-
Just Submittee.
Yeah, you will only submit to. You'll submit your code to Submittee just like it was a homework.
okay.
Okay, just think on the homework model.
I have a question on that part there on the homework model. Do you also want us to have like the explanation to what the code is and like an example, like a test example on the like top, like we would for the homework, or can we just have the code?
You just have the code. Now I'm gonna give you a caveat. If you're making an assumption, like if you don't know what we're asking, and you say, "Man, I don't know whether it's A or B," or if I don't know whether they're asking me to have 30 decimal places or 3 decimal places, put a comment in so we know that, right? That's your chance to tell us I thought your question was unclear, and I think that this is the way you wanted me to go. We'll at least take a look at it and decide whether you made a reasonable assumption or whether you just made an assumption that made the problem really easy, and then decide where to go from there. So you don't need comments, but if you want to convey something to us about how you interpreted the problem that you don't think was clear, then please put in a comment, and we will at least read it. Okay.
Oh, sorry. Actually, I had one more question.
Sure.
So there was, I guess, talk in the chat about it being open note.
Mm-hmm.
Would that just apply to the ones that we've written down, or does that also apply to the lecture notes on the
No,
computer
you
science
can use the lecture notes.
Okay.
Okay. That's why we're doing this as kind of a homework thing. Quite honestly, is it's too hard to police all of these other things, right? So we're just going to give you something where you have to think, and we'll hope that works out. Okay.
Okay.
All right. Anything else? We are winding down to 4:24. I think people are going to have a hard time viewing this video. I'm not sure I'm going to be able to get this video up before the test starts, but I will definitely try. All right, everybody. I think we're going to cut it now. My voice is starting to go. Yes, multiple submissions are allowed. In fact, I would recommend that every time you finish a section, you add it to your submission and hit submit. That way you don't get caught at the end not having something submitted. So you can submit as many times as you want. You're not going to get any feedback, so you have to find your errors yourself. Okay? Multiple submissions to the exam. Yep. Good luck, guys. I'm rooting for you.
Thank you.
Thank you.
You're welcome.
Thank you. As long as there's no gumball. I think
You
I'll be
never
good.
know. That's one of my questions.
Oh. Okay. Well, thank you so much.
You're welcome. We'll see you guys later. And like I said, good luck to everything.